Hey everybody. I'm going to get started with a question. Does anyone know who this is? Show of hands. One person. Yeah, so this is Stevie Ray Vaughan. He's one of my favorite guitarists, and he's also the reason that I have a Sunburst Stratocaster, though his is a little more beat up than mine is. And if I'm being honest, that's where the similarities between Stevie and me kind of end. You see, he's good at playing the guitar, and I can't keep up with his fashion sense. One time Stevie said, "I use heavy strings, tune low, play hard, and floor it." Floor it. That's technical talk. So that's something else Stevie and I do have in common, actually. We both enjoy some tongue-in-cheek technical talk. Thank you for coming to mine. My name is Kevin Murphy. I work at a company called Pubmark, and we make tools to help you find ebook deals, and also we have an audiobook marketplace. And today we're going to be working to teach our computer how to play the guitar just like Stevie does, because I can't play the guitar like Stevie does. So let's get started. Stevie uses heavy strings, so in order for us to be able to do that, I'm going to propose something rarely done in the world of programming. Let's have a thing called a string. And this will work, but just to eliminate any potential confusion, we'll just call our thing a guitar string. And we know our guitar string needs to know if it's heavy, but what does that mean? So a regular guitar will have 6 strings on it, and each of those strings will be of different thicknesses. Those thicknesses are measured in thousandths of an inch, and if you're going to get a guitar from the factory, it likely will be strung with a set of 9s, meaning that the thinnest string is 9 1,000ths of an inch. Stevie didn't play 9s. He played 13s. These strings are harder to manipulate, harder to press down on, harder to bend. It's more work, and he called them heavy. So to know if we're using heavy strings, we're going to check the gauge of the string that we're using, comparing it to that common gauge, and if it's higher, it's heavier. And now you and I may have called those strings thick or thin, but Stevie didn't. He called them heavy. And so we're going to use that terminology and encode that in our system so that we're speaking the same language. Each of the strings on our guitar are also tuned to different notes. There is a standard tuning you might expect if you're using a guitar. Stevie, once again, did not use standard tuning. He tuned down a half step, meaning that each of these notes was just a little lower than you would regularly expect from a guitar. So we know we need to be able to tune our guitar, and we know we need to support multiple tunings, most commonly standard tuning. And so we're going to switch on the type of tuning we get, and if we need to tune to standard tuning, we'll tune all the strings to standard, and if we need to tune low, we'll tune everything down a half step. That's not the only set of tunings you can tune your guitar to. There are a lot of them. There's a lot more than this. This is just all that would fit on a slide. And as much as this method is becoming a bit unwieldy, overall, our entire guitar class is starting to become inundated with a bunch of information about tuning, such that you might reasonably conclude, if you're just scanning through this class, that a guitar is an instrument that's primarily used in order to tune itself. Which is a thing it can do, but it can also do a lot more exciting things, and this is just taking up a lot of real estate in our mind when we're just looking through this about everything that a guitar does. So we still want to be able to tune our guitar, but let's instead use a separate tuner class to handle that for us. That tuner class will take in a guitar as a constructor argument and will handle the details about how to tune our guitar. We have the same functionality in our guitar class, but the details about how to tune are now isolated in that tuner class. So if we need to know how the tuning actually works, we can look there while still having the same API on our guitar class. What got us here is being able to extract all of this tuning behavior into a separate named class that lets us isolate all of that into one place. So how do we actually play the guitar? Well, here is going to be probably the quickest and mostly correct explanation you'll ever get about how to play the guitar. Let's focus on one string first. Because we called it a string, let's tune it to the note of A. And what this means is that if you were to pluck this string, if you were to play it without any other modifications, it would play the note of A. But that doesn't mean it's the only note that you can play on that string. A guitar has a neck that's broken up into different sections called frets. And when you place one of your fingers down on one of those frets, it compresses the string, makes it a little shorter, and plays a higher note, which just happens to be the next note available to you in the world of music, on and on up the neck for all of the notes. Now, we don't say we play the guitar string, we say we play the guitar, so we're going to have our main interface be on the guitar class, and we'll be able to use our guitar pick to play a string at a particular fret. In order to do this, what we need to do is call the write strings pluck method. And that's all there is to playing the guitar. And it's really lightweight because we have delegated all of the responsibility onto the string class to really handle the details about turning that input into a note. The guitar is responsible for knowing where to send the right message to, and then the string class handles the rest for us. So let's put some of this all together. Let's grab a guitar, put some heavy strings on it, tune it low, and pick some music to play. Stevie was known for playing the blues, so we're going to play some blues. And what we get are all of the notes in our song. This is great. We have taught our computer how to play the guitar. Presentation over. I do have more. Let's look at some of the inputs, some of the things we asked our guitar to do during the course of this song. Early on, we asked it to play the 5th string at the 1st fret, and when tuned down a half step, that is an A note. And later on in the song, we asked it to play the 3rd string at the 3rd fret, which is also an A note. But these A notes aren't the same. They're different octaves apart from each other. One sounds higher than the other, but with our current output, an A note is an A note, and we make no distinction there, and we're losing some critical information to be able to understand what this actually sounds like. So let's try again. What we want is to be able to play our song and see not only the note, but also the octave. So in order to do this in our string class that's handling our details for us, we're going to return both the note and also the octave as an array of elements. And so now in our song, when we're playing each of the notes, we're going to output the first value and the last value, the first value of which is the note, and the last of which is the octave. And I know that because we just looked at that method. But if I was just reading this in isolation, I would have no clue what any of this means. So instead, rather than returning this array, let's instead create an object called a note class. That note class will respond to the value and octave messages. And then in our song, we're no longer going to be asking it to output the first and last value. We'll ask it to output the value and the octave. We got a nice readability win here. We could have achieved this by using a hash, right? A little different syntax, but we have the same readability. But now that we have this bundle of data that's all put together, we can also assign some custom behavior to it. So now we can ask the note class to be responsible for knowing how to output itself into the world so that our song doesn't need to be concerned about it at all. It can just ask the note to do it for us. Right. And now we can focus on playing our music with our song, and everything looks just the way we would expect with our notes and our octaves, and we have all the information that we need. And what helped us here is taking what was a primitive data structure, an array of elements, and converting it into an object that gave us a rich API to be able to understand what this data is. And after getting that readability win, we also had an isolated location to attach behavior to it. And that's it. That's how to play the guitar, right? Any of us now could come up on stage, bring our computers, and sound just like Stevie does, delighting audiences the world over. Except in a room of this size, it would be pretty hard for people to hear you without some amplification. And as you might have guessed from our prior quote, Stevie wasn't much for talking about the details about gear and the technical implementation. So in service of that, I'm going to give a really brief introduction about how guitar amps work. An amplifier is a tool that amplifies sound. And it does that by progressing through 2 stages. There's a preamp and a power amp. We have now just built a fully functional amplifier. That's it. That's all there is. Now, there are a lot of different types of amplifiers. We're going to talk about a few of them here. The first is called a tube amp. Tube amp gets its name because of the electrical components it's built out of. It uses vacuum tubes or valves, depending on the part of the world that you're from. And guitarists like these vacuum tubes because of the way it makes their guitar sound. They say it provides a particular warmth that they really enjoy, and when you really crank it, it gets super warm, and they just love that. Now, these tube amps are quite heavy, so it's really annoying to lug them on and off stage, but it's worth it because of how it makes your guitar sound. And now with all of this functionality, one thing our tube amp can't do yet is amplify sound, and that's kind of important. It's a core feature of what an amplifier does. And we already have a fully functioning amplifier, and this tube amp should act the same way as that amplifier does. So we're going to inherit from the amplifier class. That will give us access to all of that behavior, such that with this change, now our tube amp instances all know how to amplify sound. We also have solid-state amps. Solid-state amps work a little differently. They also have a particular tone that they provide. They put clarity onto your sound. They're clean and clear as glass. And that clarity persists whether it's just turned on or fully cranked. And these solid-state amps are built with a little more modern of electrical component, a new thing called a transistor. And that means that they're light, so they're easier to carry around, which is beneficial, and they come in different form factors. Now, our solid-state amp also needs to act like any other kind of amplifier, so we're also going to inherit from our amplifier class. And now our solid-state amp also knows how to amplify sound. And so for both our tube amp and our solid-state amp, we used inheritance to have a consistent API and set of behaviors that we respond to, while also applying specialization on top of that. Our regular amplifier class is fully functional and doesn't change the input sound at all, while our tube amp applies its stereotypical warmth, and our solid-state amp adds clarity. So one other kind of amplifier we're going to talk about today, it's called a hybrid amp. It's a best of both worlds solution, pulling in bits and pieces of a tube amp and parts from a solid-state amp. So we can try to take a similar approach to building our hybrid amp and say that a hybrid amp is made up of behavior from our tube amp and from our solid-state amp. And if we try to run this, we'll get a syntax error. And the reason for that is because Ruby doesn't support multiple inheritance. You can't inherit from more than one thing directly. So we need to consider a different way that we're going to get access to all of this behavior on our hybrid amp. And to do that, let's think back to what our amplifier is and how it works. It's built up of two different components, a preamp and a power amp. So let's separate those and build them individually. A hybrid amp uses the same preamp as a tube amp. So we're going to take all of the behavior that's related to a tube preamp and put it in a module to put all of this behavior in one place. Notably, the tone, so we're going to have our warm tube amp tone in our tube preamp. And now for our hybrid amp to be able to access this behavior, we're going to include that module, and that will allow instances of our hybrid amp to have the tube amp warmth without having to write it itself. To have a functional amplifier, we also need a power amp, and a hybrid amp uses the same power amp as a solid-state amp, which is lucky for us because those are lightweight. And now to access this behavior, we can also include that solid-state power amp because we can include as many modules as we would like in Ruby, unlike the number of classes we can inherit from. And now our hybrid amp also has a lightweight power amp. And here we used module composition to be able to share behavior through our classes. Right? Our tube amp is now also going to include the tube preamp, and the preamp tone method is going to be deleted from our tube amp entirely, so we have a consistent place where all this behavior lives. Now our hybrid amp also needs to behave like any old amplifier, so we are going to use inheritance here, but we're going to inherit from the amplifier class. And now our hybrid amp can actually amplify sound. So we've built a couple of different amps. We've built a guitar. Let's put them together. Okay. Let's grab an amp, turn it on, pick up our guitar, play our blues, and for each note that comes out of our guitar, we're going to send it through the amplifier. And by doing this, we see the note and the octave that we saw when we were previously playing the song. We see the tone that the amplifier adds onto it, and also the volume that the amp is set to. And we see that for all of the notes that we're playing in our song. And this is great. Our guitar and amplifier are working together, but it doesn't match our mental model of what it's like to play the guitar. See, playing the guitar is hard enough. It's even harder if you're responsible for plucking sounds out of the air and pushing it through an amplifier, right? You don't need to interface with the amp at all when you're playing the guitar. The guitar does that for you. It has pickups that takes the electrical signal and sends it through its cable into the amplifier, so you don't need to worry about it at all. So what we want is an API where we can focus on our guitar and playing the song without having to deal with our amplifier at all. Now to do this, our guitar still needs to know about our amplifier, so when we create a guitar, we'll also set up an amplifier. And now for each note that we play, we will send that resulting note to the amplifier, and by making this change, now we can play our guitar with the API we want and still see it amplified through the amplifier. But we built a whole bunch of amps. It'd be a shame not to use them all. And so now if we want to try a different amp, we need to change our guitar class from using a solid-state amp to instead using a cranked tube amp. When we do that, we can play our song and get our warm tone that we would expect. But we're going to be switching amps out quite a bit, and we don't want to have to make a change to our guitar class every time. So instead, let's accept it as an argument in our constructor. So we can use any amplifier we would want when we're creating this. This is a term called dependency injection, and this allows us to create a guitar that will work with a solid-state amp or a guitar that will work with a tube amp without having to change our guitar class at all. This dependency injection gives us flexibility to let us decide later on, a little closer to runtime, how we're actually going to define the way that these things work together, but we know we have a common interface to do it. So let's flip through some of the things we've been talking about here. A lot of this we've been talking about ways to share and compose behavior in our systems, and we've talked about a number of different ways to do that. Right, we used inheritance to build our amplifiers, and we also used module composition. We also composed behavior when we were building our guitar. Right? Our guitar knows how to tune itself, but it only knows how to do that through the tuner method. And our guitar knows how to work with an amplifier, but it needs to be told what the amplifier is at the time that we're constructing our guitar. So what do we use? The good news is we've shown in this presentation that all of these will work. They just have different trade-offs and constraints you need to apply. And what it comes down to is knowing how you plan on assigning those constraints in your system. So for us, we were building a tool that allows guitarists to play the guitar. So we want to be able to use amplifiers, but we don't want to have to know the internals and details of our amplifiers. We want to have them work relatively consistently. They should all amplify sound without us having to worry about that. So we used inheritance here to be able to define a common interface through which they'll all work together. We didn't need the flexibility of knowing the internals and guts of the amplifier. Right? That's because we're building a tool for guitarists. If we were instead building this for guitar techs or a repair shop, they might literally need to take preamps out of one amplifier and into another. We don't need that flexibility here, so we're not going to build it, because if we build it, then we have to maintain it. We do need that flexibility for our interface with our guitar and our amplifier, though. Right? We want to be able to support using a lot of different amplifiers for our guitars, so we're providing that flexibility in our interface here. We also have a lot of functionality that comes from our guitar, but we don't need to be bogged down with all the details inside the guitar class, because we've extracted a number of collaborators that handle those details for us to give us that class with that API without needing to know the inner workings unless we're interested there. And by making those choices, by choosing those constraints, we're able to focus on what we want to do, which is play music. And this is wonderful if you can read this and translate it to music in your head, which you probably can't, and that's not a knock on your musical ability, but is entirely a result of the fact that I made this notation up for this presentation. As far as I know, there's no standard emoji to guitar amplifier conversion, and if there is, I didn't use it. And even if you might be able to see a D note at the third octave, you might not be able to translate that into what that actually sounds like. You might need to actually hear this to know if the music that's playing is actually any good. And luckily, we've built our system such that we can interface with a lot of different amplifiers to provide different output that allow us to actually define that output. So The next time you're composing behavior in your system, I hope you think about these examples in this presentation. If you'd like to listen to this song on your spare time, because who wouldn't, you're welcome to do so at kevinjmurphy.com/playguitar. While you're there, you can also get a copy of these slides, access to the code examples, and also some blog posts on related topics. I'm happy to answer any questions individually. I'll hang out over there on the side of the stage. Feel free to come over and say hi. I also brought my guitar, so if you think that I've prepared you to be able to play just like Stevie did, you're welcome to try. Just please be respectful to others around you and also the instrument itself. I quite like it. I want to thank the organizers, Gemma, Emily, and Andy, for putting this all together and putting us together in this room. I want to thank all of you for being here. I hope you have a great rest of your conference. Thank you all very much.